Okay, number 8. The function, okay, the function fx equals sine x over x, right? And then they ask you to find the limits x approach to a from this negative sign here means what? From the left side, okay? So just like here, you have a number line here, okay? Suppose this is the pi. And right now they ask you, this is the x, huh? So they ask you x value go approach to the pi from the left side. We know pi equals what? 3.14, right? Maybe this one approach to that one just like getting closer to this 1.11, 3.11, 3.13, close to the 3.14, go this way, right? So when you go this way, the top part here, sine pi. So you gotta sine pi over what? This one just close to pi, huh? Just like, for example, like 3.139, like that, right? But we know this one close to, because this one also 3.139, like this one, right? And the sine of this close to what? Will be equals to 0. Sine pi equals 0 in general. Huh? Sine pi will be equal to 0 because this function is continuous for the sine. So sine pi, you can plug in the pi in here, so you make it equal to 0. And then the bottom one is not 0, so that means the overall 0 over the number which is not 0, right? We can put it this way at the pi, okay? So this one we can put it because of approach to pi, and since it's continue, we can plug it in here. So that will be equal to what? 0. This is left limits. And then when you go to right limits, that means this time the function, the x value go from the right side approach to this pi, right? And when the approach to the pi, you will have what? Like 3.15 on this side to go, okay? Go this way. And when you go this way, this one pi, you can get a pi. And here you got a what? Sine, also sine pi. But sine pi will be equals to what? 0. So you have a 0 over pi equals what? 0. Since left limit equals 0, the right limit also equals 0. So the limits exist. So this one will be equal to 0. Okay? Now let's look at the number 9. Number 9, we do the same thing of this ABCD. Okay? For number 9, there's a little bit different now because the bottom here is what? Greatest integer function. For example, this one here, they told you this is the x, and for the number 9, right? I put number 9 here, okay? So for the number 9, you will get a what? This is 9, huh? Like this, okay? For number 9, you will see that this one, suppose this is a equals 3. So we need to do the similar one. We do the a will be what? Limits. We need to find the limits when the x approach to 3 from the left side. Means go this direction, approach to 3. That's just like a 2.99, 2.9999, like that, close to 3, right? So when this one approaches 3, what happens? The sign, of course, this is the pi. No problem with that. Oh, wait a minute. So this one here, on this part, the limits, this one will be just the pi on the top, no change. But the only change here is the bottom part, this one here, okay? When you have this part, you go this way, because this function means what, like this one? you have a 2.99 like this one here. This is called the greatest integer as big as possible, but still less than 2.99, which is only 2. So this is the lower one, is 2 here. So this function, this value will be what? 2. Or you have a sign here, okay? Hold on. We got it here. So you're gonna have sine, right? This is the pi over the bottom one here will be the 2, like this. So when you have sine pi over 2, that will be what? Sine pi over 2 equals 1. That's 90 degrees, huh? But if you go to the b, you want the b here. If you find what? The limits x approach to 3 from the right side. If you go from right side, the sine pi over box x, like this, right? When you do that, you see here, this one can go this way. This way is what? You like a 3.01, go this way, huh? As long as this number bigger than the 3, you can see this value 3.01, like this, right? This one equals what? Greatest integer less than 3.01 will be 3. It's the greatest integer possible. So you will end up with pi over 3. And you will end up with this. So sine, right? Pi over 3. Pi over 3 equals square root 3 over 2. This 2 not equal. So this one not equal. Oh no, not this one. Oh no. Means what? Means the left limit 1 and the right limit root 3 over 2. This 2 not equal, right? This one not equal. If they're not equal means what? The limits, so when we go to the C here, the limits x approach to 3 sine pi over the greatest integer function x will be not defined. Okay? And it's not available. Okay? So let's recall what we did here for both 8 and 9. The left limit, we just say when x approach to that number, like this one pi, from the left side. And the right limit, it goes to this way for the right side. But since this function, sine x and x, they're continuous. Each of them continues. So you just plug it in, you got it. But the problem for the number 9 here is a little bit different. Because this integer, when x approach to 3 from the left side, the graph will be like this, okay? Like this one here. You can see there is a jump. For example, this is 3, right? This is a 1, 2, 3, like this, huh? So if you're on this side, the function value will be what? Just, so this is a 1, this is 2, right? So when you go this side, there will be 2. So function value will be 2 here for this. But not 3 though. When it's 3, it will be 3. When it's more than 3, if you're on this side, x approach to the 3 from the right side, like 3.01. From this side, x approach this way, there will be jump. Go this one, like this. So that's give us the idea. If the function here, the part of this one's greatest integer is not continuous, so we can see the left and right limits were not equal. So that's why the limit was sine pi over greatest integer x. When x approaches 3, is not defined. Okay, that's the one. All right. So if you have any questions, please let me know. Thank you. Bye-bye.